Wait, yeah, all right, cool. Thanks. Hello, everyone. I unfortunately cannot see you, to be honest. But thanks for showing up. My name is Chris, and today I'd like to talk about the interesting topic, open source firmware, right? Why do we need open source firmware? What's the current state of open source firmware? And what are the pitfalls that we're seeing right now? Like what arises from open source firmware right now? And I'm working for a company called 9 Elements. We also have a nice booth on the floor there next to AMD, so feel free to swing by. And I want to talk about let's put back open into open system firmware. And what we basically want is we want to unlock open source firmware. And to give like a very small introduction, actually, that image was AI generated, right? So I tried to adopt here. And what is firmware? Firmware is basically software in the end, right? It's like a very specialized part of software. It interacts directly with hardware, but in the end it's software. And firmware is the most privileged software that runs on your system. On every system it can read everything, it can write everything, and it has a lot of implications. It has implications on security. If you got malware in firmware, like the whole system is basically broken. It has implications on usability. It has performance implications. Imagine your system boots up for 50 minutes. That's kind of a usability and performance issue that they have here. And also it has implications on time to market. If your firmware development is not up to pace for your hardware development, that's really a bad thing to do. And it can have implication on the price that you're paying and on the bill of material that you actually have in the hand. So you see that firmware is a very critical component of your system. And actually, not sure if you visited the talk in the morning from Amanda Brook from Open UK, and she said that 48 to 90% of the software that gets written nowadays is open source. However, firmware did a pretty decent job to stay out of that corner for a very, very long time. And this is actually about to change, which is pretty great to see. And what do we have in firmware? And I'm really talking more about host firmware and baseboard management controller firmware. I know there's like a lot of network controller firmware and all these kind of things. But like where I come from, I'm very like host and BMC basic. And we have core boot, obviously, core boot and Linux boot as the go-to projects for the OCP at least. We have ARM-based solution with ARM-trusted firmware. We have EDK2-based firmware on the host side of things. And on the BMC, like nowadays the default solution on BMC systems is really OpenBMC. And then there's also like a small, nice project that I like, which is like UBMC. You can also check that out with us. So this is like the ecosystem that we talk about in terms of host firmware and BMC firmware. And the journey, how we get there, so where we are now is it kind of started, at least on the server side of things, with Broadwell DE a couple of years ago. Intro released the FSP 1.0, and Facebook was actually doing a proof of concept with the Broadwell DE switch. Which they brought up with core boot and Linux boot running open source firmware as one of the first of their types. 2018, also Facebook pushed for Skylake scalable, like the first Xeon scalable chipsets that was also in a proof of concept state. And actually, like the big breakthrough was in 2020, where Cooper Lake was running FSP, or was supporting FSP, and it was supporting core boot and Linux boot. And a Cooper Lake platform, the OCP Delta Lake, was actually the first platform that got OCP OSF certified running open system or open source firmware. So that was like a pretty good breakthrough there. Ampere is doing open source firmware since 2020, running EDK2 on their system. 2021, the Sapphire Rapids effort started, where really a couple of companies came together, like Facebook, Google, 9 Elements, Intel, WeWin, Supermicro, and they joined forces together to bring open source firmware on systems. at a big scale. Also, Ampere is still in the open source firmware game. And actually, last week, AMD announced to have AMD's OpenSil, where they support open source firmware as a proof of concept on AMD Genoa-based platforms. So what we can basically say is that all major SoC vendors nowadays support open source firmware. So that's a great thing to see, and it's a great thing that evolved over the last years. However, why are we using open source in the first place, right? I mean, that's a valid question. And there are studies that show enhanced security on open source software. We obviously have transparency in the software, so you can look into it, you can see what's going on, you can evaluate it, and see, what's in there. We showcased, especially on the Sapphire Rapids effort, that accelerated innovation comes through collaboration of different companies, working together on that. And customers or people using open source firmware have the ability to customize and customize their own solution, have like tailor-made solution. Also, there is a cost-saving point in using open source firmware and collaborate with each other. However, the downturn is what we're seeing is with the rise of, open source firmware gets way and way more popular, and with the whole rise of open source firmware become more and more stable and mature in the industry, we see pseudo open source solutions. So what companies tend to do nowadays is they claim to support open source firmware. However, what you actually get is like a limited version of the actual thing. And that boils down that you need to pay in order to use the full functionality, right? So you get like a limited crippled piece of software, and that you can use. However, you need to pay to get like production-worthy code, and that creates like a vendor-locked lock-in for people who use it. And in the end, it's like a very bad user experience because it harms the whole open source firmware ecosystem. It hinders collaboration, obviously, right? You're working on a piece of software that is not meant to run at full scale. It creates fragmentation in the open source ecosystem, and it actually reduces the trust of open source itself. Because the user experience is obviously, it has to be horrible, right? It is meant to be not as good, right? That's why you need to pay. And that reduces the trust of overall open source firmware. And obviously, around this kind of software, little to no community interaction will be there because there will be no community around it. However, what should be the way is that we have like an open source model where we have a piece of firmware that is always up and functional at its full capacity, right? So we have firmware, we have security in there, you get security patches, it should be up to date all the time. You have all the functionality, it should not be crippled. And actually the value add that should be coming in from companies selling firmware should be more on the UI kind of level, should be more on the device management, updatability, providing support to you than rather limiting that piece of software that you should use there. Also, with the rise of open source firmware, the platform enabling model kind of changes. So the traditional model actually was that it was highly controlled by the SoC vendor. The SoC vendors controlled who gets the reference code and who gets the documentation and who not. Also, obviously, SoC vendors work very closely with IBVs to enable those, and then the IBVs enable the ODMs and OEMs. And with an open development model, this platform enabling model actually changes. So it's a more scalable approach. So the SoC vendors actually work with enablement partners, which could be OEMs, independent software vendors, any SoC, ODMs, community, IBVs, name it. Like a big group of company working together and pushing collaboration throughout these companies to enable the platforms together. This is a way, way more scalable approach, and you can enable a way faster and way more like OEMs and ODMs actually than with the traditional model. Obviously, the downturn here is that the SoC needs to provide support to the enabling partners, and this is something that is still lacking. But we're slowly getting there. And this is actually what 9 Elements does, right? We are a company that writes open source firmware. We are involved in all these major open source projects like Coreboot and EDK2 and OpenBMC, working together with companies, enabling their platforms. However, we adopted an upstream first, open source first development model. So everything that we write will land upstream and will land in open source. We have a very unique business model, so you can customize it to your needs. We can do whatever you want us to do. It's very modular, and it's very, very custom-made to your needs. We have been involved in the Sapphire Rapids effort that I just talked about before, where Intel was working together with like Meta, ByteDance, Supermicro, WeWin, and also 9 Elements. That's one of the IBVs involved in that effort to enable Intel Sapphire Rapids platform with Coreboot and Linux boot. And it was like an industry-wide approach or an industry-wide effort actually steered by the Open Compute, Open System Firmware group, and namely by Jonathan Stang. And the output was really production-ready platforms from Supermicro, from ByteDance. ByteDance is actually putting that in production right now on their server systems. And also you can buy WeWin servers with open source firmware off the shelf. Also, we've been involved in the AMD OpenSil effort. I don't want to talk too much about it because Raj Kapoor, like the chief firmware architect of AMD, will have a great talk about this tomorrow, about AMD's approach to OpenSil. But we also were partnering up with AMD on enabling open source firmware on GNU platforms. And if you want to know more about that, we have a booth, as I said, right around the corner, and we are really looking forward to show you open source firmware and what it's capable of. We have like Coreboot systems for Intel and AMD platforms, so feel free to drop by and talk with us about open source firmware and a better way to write firmware. Thank you so much.